In this video, I'm going to tell you about delta time and the update loop in Unity. The update loop is a fundamental part of modern games. All the code in the update loop runs every frame. Frames are just like frames in a film. They're static images that, when displayed one after another, create the appearance of smooth movement. In this sense, we could think of our game as a film where each frame is set up and rendered right before it's displayed. The delta in delta time comes from the Greek letter delta, which is used in mathematics to mean finite difference. So delta time is the amount of time that's passed since the last frame, or the difference in time between two frames. Delta time is important for a number of reasons. For example, in the image we see here, we see 3 frames of a sphere moving up. The sphere has a speed, and that speed is distance over time. The delta time allows us to calculate the distance that sphere should move from one frame to the next. In our earlier script, we simply added a small amount to the position to move the object. This is actually a bad practice and can cause problems. For example, consider 2 identical games, except one is running at 120 frames per second and the other is running at 30 frames per second. If we let each game run for 1 second, the object in the game running at 30 frames per second is only going to move a quarter of the distance of the object in the faster running game. Using delta time, we can give our game more consistency, regardless of the speed it runs. We call this frame rate independence. In Unity, delta time is measured in seconds. This means that when choosing a speed, it'll be x units per second. The unit in this case will vary from game to game. We could use inches, feet, yards, whatever we like. By default, Unity uses meters. An example of this would be if an object's speed was 3, after 1 second, the object would have moved 3 meters. In order to move n meters per second, we're going to scale the speed by delta time. Imagine that if delta time was 1 second, that would mean our distance traveled would be equal to speed times 1. This is great since we want our speed to be n meters per second. Of course, delta time is typically much smaller than 1 second, so the distance moved should be fairly small. Let's see this in practice and update our code. So simply removing the constant amount here and adding a small amount, so 3 times time delta time. Now our object will move up at 3 meters per second, no matter the frame rate. Let's see this in practice. We'll save and switch back to Unity. There it goes, up out of the screen at 3 meters per second. In this video, I've shown you what delta time is, why it's important, and how to use it to produce more consistent results. We also looked at a high-level view of the behind-the-scenes workings of Unity in the update loop. Using what we know about the update loop and delta time, we can achieve frame rate independence in our game. Frame rate independence is important because it provides a deterministic experience regardless of the speed the game runs.